Good morning, students. Today we are going to discuss about the new chapter chemical kinetics. Here, kinetics means speed or rate of a reaction. Chemical kinetics means we discuss about the rate of a reaction or speed of a reaction. So, it is a branch of chemistry, explains about or deals about rate of a chemical reaction or speed of a chemical reaction. Again, we are going to discuss about factors affecting on rate of reaction. Under this chapter, next other topics are factors affecting on rate of reaction and mechanism of the reaction. The main definition of this chapter is chemical kinetics means it is a branch of chemistry, deals with the relationship between speed of a reaction, rate of a reaction, mechanism of a reaction, explains about the mechanism of a reaction and factors influencing the rate of a reaction. So, here for any chemical reaction, we need to understand three things. One is delta G of a chemical reaction, direction of a chemical reaction, rate of a chemical reaction. First one, delta G. Delta G means we know gives free energy change. Already we discussed about this one in first year thermodynamic chapter. Next, direction of a reaction. This is also discussed in equilibrium chapter first year. Now, we are going to discuss about the rate of a chemical reaction. Again, for any chemical reaction, we need to understand three things. One is gives free energy change. That means spontaneity of a reaction. Spontaneity means whether the reaction is feasible or not, possible or not under certain conditions. If delta G is equal to negative means reaction is feasible. If the delta G is equal to positive means reaction is not feasible. If the delta G is equal to 0 means reaction at equilibrium. So this is about delta G. Direction of a reaction means the reaction takes place towards the forward direction or towards the backward reaction. This is about the direction of reaction. Now we are going to discuss about the rate of a reaction, that means speed of a reaction or kinetics of a reaction. Based on the rate of a chemical reaction, generally chemical reactions are classified into three types: very fast reactions, very slow reactions, moderate reactions. Very fast reactions, very slow reactions and moderate reactions. First one, very fast reactions. Very fast reactions are means the reactions which takes place very fast. The time taken to complete the reaction is around 10 to the power of minus 14 to 10 to the power of minus 16 seconds. These reactions are examples are ionic reaction. Ionic reactions are examples under very fast reaction. So, it is very difficult to calculate the rate of a reaction. If the reaction is very fast means we cannot calculate the rate. Example, ionic reactions. In that AgNO3, silver nitrate plus NaCl, silver nitrate react with NaCl gives the precipitate AgCl plus NaNO3. This is one example of ionic reaction. It is a very fast reaction, so we cannot determine the rate of a chemical reaction. This is about very fast. Next one, very slow reaction. Very slow reactions are covalent reactions. Example, rusting of a iron or H2 hydrogen react with oxygen at room temperature gives H2O. This is also very slow at room temperature, so we cannot predict, we cannot calculate the rate of a reaction. Next, moderate reactions. Next, moderate reactions. Moderate reaction means the reaction speed is moderate at room temperature. Those are called moderate reaction. So if the reaction speed is moderate, we can calculate the rate of reaction. Example, decomposition of hydrogen peroxide H2O2 gives water plus O2. This is decomposition of hydrogen peroxide, moderate reaction. If it is moderate means we can calculate the rate. Next one, hydrolysis of sucrose. This is sucrose C12H22O11. Hydrolysis of sucrose will give glucose and fructose. Formula C6H12O6. Here also C6H12O6. Difference is aldehyde function group is for glucose, ketone function group for fructose. So sucrose hydrolysis to give glucose and fructose. These are the moderate reaction. So for moderate reaction, we can calculate the rate. Next up. Here, generally reactions are classified into two types. Those are simple reaction, complex reaction. Simple reactions are called elementary reaction. Complex reaction means multiple step reaction. Single step reactions are called elementary reaction. If the reaction is not in single step, it is not completing in one step, that is called complex reaction. Single step reaction, complex reaction. In complex, side reactions will take place. Instead of product, again byproduct will react, it will give one more product. So complex reaction, elementary reaction. So reactions are classified into two types: simple reactions, elementary reactions, and complex reaction. Elementary reactions are nothing but single step reaction. Here complex reaction means multiple step reaction. This is about definition of elementary reaction and complex reaction. Next important topic is rate of a chemical reaction. So rate of a reaction means speed of a reaction. How to calculate the speed of a reaction? Or what is the rate of reaction? What is the speed of a reaction? Here see, one reactant is there. R is reactant, C is the product. Reactants are converted into product. Reactants are converted into product means by the time consumption, reactant concentration gradually decreases, product concentration gradually increases. So initially only reactants will be present, products are 0%. By the time consumption, reactant concentration gradually decreases, product concentration gradually increases. So change in concentration of reactant and product at unit time is called rate of a chemical reaction. Change in concentration of a reactant and product in a unit time is called rate of a chemical reaction. So initially in any reaction, reactants are present, reactants are 100%. Product concentration is 0. By the time consumption, reactants are converted into product, that is called chemical reaction. Reactants are converted into products means reactant concentration decreases, product concentration increases. Now we will see reactants are converted into product. At time 0, initial time, reaction not yet started. At that time, reactant concentration is 100%. Product concentration is 0%. At T1 time, after 1 hour, here reactant concentration is decreased from 100 to 80. 100 to 80. So this is decreasing concentration 100 to 80. Here 20% is converted into product. So total is 100. Reactant concentration is decreased from 100 to 80. Rest 20% is a product. This is R1. This is P1. Here this is R. This is P. At T1 time, reactant concentration is decreased. Product concentration is increased. Next, at a T2 time, after 2 hours, reactant concentration is decreased to 60%. 60% decreasing concentration. So, here 40% is of product. If it is irreversible reaction, by the time consumption, reactant concentration is reaches to 0, product concentration is reaches to 100. This is for irreversible reaction. Now, we will see delta R, change in reactant. Change in reactant concentration here. Change in reactant concentration R2 minus R1. R2 minus R1. R2 minus R1 is here 60 minus 80. So you will get the value, negative value. So delta R is negative value. Why it is negative? Decreasing concentration, negative. Next, delta P, change in product concentration. Change in product. The square bracket represents the concentration. P2 minus P1, 40 minus 20. So it is a plus value. Increasing concentration of product. Again, reactant concentration initially is 100%. By the time consumption, reactant concentration gradually decreases, product concentration gradually increases. Initially, reactant concentration is 100, product concentration is 0. By the time consumption, 1 hour and 2 hours, reactant concentration gradually decreases, product concentration is gradually increases. Then what is the rate of reaction? Rate of reaction with respect to the reactant, minus, why it is minus? Decreasing concentration, minus change in concentration of reactant by change in time. By the time consumption, reactant concentration is changing. Here changing is decreasing, negative value, negative. Rate of concentration, rate of reaction with respect to the product. With respect to the product concentration is increasing, plus dP by dt. Now units for rate of a reaction, this is called rate of a reaction with respect to the reactant, this This is rate of reaction with respect to the product. Now rate of reaction units, concentration units, moles per liter. Moles per liter means liter inverse. Time in seconds into second inverse. This is about units and definition of rate of reaction. Next we will discuss graphical representation of decreasing concentration of reactant and increasing concentration of product. We discussed about the rate of a chemical reaction, units of rate. Now we will see rate of a reaction with respect to the reactant and time graph, with respect to the product and time graph. Here this is one graph plotted in between concentration of reactant to time. Here reactant with respect to the reactant. Then initial concentration of reactant is 100%. By the time consumption, reactant concentration gradually decreases. Reactant concentration gradually decreases. So this is the concentration of reactant R1 at T1 time. This is the concentration of reactant at T2 time. So this slope is negative slope. R2 minus R1 negative slope. So this is the decreasing concentration of reactant. Here, increasing concentration of product. By the time consumption, product concentration gradually increases. Here, by the time consumption, reactant concentration gradually decreases. Here, product concentration gradually increases. Initially, product concentration is 0. By the time consumption, product concentration gradually increases. Here, the product concentration P1 at T1 time. Here, product concentration P2 at T2 time. Here P2 is a higher value, P1 is a lower value. So P2 minus P1, positive slope. So this one is a minus d delta R by dt. For this one product with respect to the product rate of reaction plus delta P by dt. Here with the rate of reaction with respect to the reactant minus delta R concentration of reactant by dt. Here product concentration increasing, so rate of reaction with respect to the product plus delta P by dt. This is about rate of reaction with respect to the reactant, rate of reaction with respect to product. Here in place of delta we can take D also. Delta is if the difference is more, that is a delta. If the difference is less, we can take D. Now average rate of reaction. Average rate of reaction definition is the rate of reaction with respect to the reactant with respect to the product, change in concentration of reactant or product in the time interval, within the time interval is called average rate of reaction. Change in the concentration of reactant or product within the time interval is called average rate of reaction. Again, instantaneous rate of reaction. Instantaneous reaction means the change in the concentration of reactant or product at instant time is called instantaneous reaction, rate of reaction. Now remember what is the delta and what is D. If the difference is concentration difference is more, delta. If the difference is less, D. Next we will see rate expression. Rate expression is, we know reactant concentration gradually decreases, product concentration gradually increases. So reactant concentration is always represented with minus sign, product concentration is always represented with plus sign. If moles are there, number of moles also there, the expression is like this. See, here our reaction. Capital A, capital B represent the reactants, capital C, capital D represent the product. Capital A, capital B represent the reactants, capital C, capital D represent the product. Here N1, small n1, N2 are number of moles of reactants, M1, M2 are number of moles of product. Again N1, N2 number of moles of reactant, M1, M2 number of moles of product. C, D are products, A, B are reactants. Initially only reactant will be present, 100% reactants, 0% product. By the time consumption, reactant concentration gradually decreases, product concentration gradually increases. So here decreasing concentration is minus sign, increasing concentration is plus sign. Here see rate is equal to N1 number of moles minus, why minus, reactant concentration decreases, minus 1 by N1 number of moles are in denominator into delta A by delta delta T, change in concentration of reactant by change in time, is equal to minus 1 by N2 delta B concentration by delta T, change in concentration of B by change in time, is equal to, here it is product, so plus 1 by M1 delta C by delta T, increase in concentration, so plus sign, 1 by M, number of moles in denominator, delta C by delta T is equal to, again plus 1 by M2 delta D by concentration of D by delta T. This is about change in concentration of reactant and change in concentration of product with respect to the number of moles. This is general equation. If we take an equation 5Br minus plus Br03 minus plus 6H plus gives 3Br2 plus 3H2O. This is reactant, these are reactant, these are product. Decreasing concentration of reactant minus sign, increasing concentration of product plus sign. Here number of moles are in denominator. So rate is equal to, with respect to this reaction, rate is equal to minus 1 by 5 delta Br minus by delta T is equal to, again minus delta, here number of moles 1 by 1 minus delta Br03 minus 1 by delta T is equal to, here number of moles 6, the reactant concentration, so minus 1 by 6 delta H plus M concentration by delta T is equal to, here plus product concentration increases, so plus 1 by 3 number of moles 1 by 3 delta Br2 by delta T is equal to, here also plus 1 by 3 delta H2O by dt. This is about representation of rate expression. Now next we will see law of mass action and order of reaction. Before that we need to discuss about the factors, few factors influence the rate of reaction. We will discuss the factors affecting on rate of reaction. Next we will discuss factors affecting on rate of reaction. Here few factors influence the rate of reaction. First one is concentration, nature of reactants, pressure, surface area, presence of light, catalyst. Last one is temperature. First one, concentration of reactant. If the reactant concentration increases, product formation also increases. So if the concentration of reactant increases, rate of reaction increases. So rate of reaction is directly proportional to concentration to the power of n. N, this is called order, we will discuss in the next topic. Now remember, rate of a reaction is directly proportional to concentration of reactant. If the concentration of reactant increases, rate of reaction also increases. Next here, nature of reactants. Here starting we discuss nature of reactant means ionic reactant, covalent reactant. Ionic reactions are very fast. Why? Because there is no breakage of bond, there is no makage of new bond. Covalent reaction means reactant bond we need to break, some amount of energy is required, and product you should make a new bond in between the new reactant molecule. So nature of reactant means ionic reactions are very fast, covalent reactions are very slow. Why? Because in ionic reaction there is no breakage of bond, there is no makage of bond. But in covalent reaction, reactant bonds will break, product bond will form. So here ionic reactions are very fast. So nature of reactant means bond energy influence the rate of a reaction. Next one, pressure. Here pressure effect will be there for gaseous reactants. If the reactants are solids or liquid, there is no effect of pressure. So if the reactants are gaseous reactant, if we increase the pressure, number of collisions increases in between the reactant molecule, the number of molecule reaches the activation energy increases, the number of molecule form the product also increases. So if we increase the pressure, number of collisions increases, product formation also increases, that means rate of reaction increases. So pressure effect for only gaseous reactant. If the reactants are solid or liquid, there is no effect of pressure. Next one, surface area. If the surface area of a reactant increases, definitely rate of reaction increases. Next one, presence of light. Here light effect will be there for photochemical reaction. All photochemical reactions will take place in the presence of light or in the presence of temperature. radical reactions are possible. Free radical reactions are possible. Next one, catalyst effect. This is important effect. Here, reactants are activated here. Those activated molecules will give the product. Reactants are giving the product. When the reactants are activated, those activated molecules only will give the product. So, the reactant need to activate here. This is called activation energy. The energy difference between here activation energy and normal energy is called threshold energy. Here this is activation energy. When this is absence of catalyst. When the catalyst is there, this activation energy value decreases. Here the potential energy, this activation energy value decreases. Then product formation is easy. This is absence of catalyst. This is presence of catalyst. If the catalyst is there, this activation energy value decreases, product formation is easy. If the catalyst is not there, activation energy value will be more, the product formation is difficult. This is about catalyst effect. Next, temperature effect. If we increase the temperature, rate of reaction increases. So, rate of reaction is directly proportional to temperature. For every 10 degrees rise in temperature, rate of reaction is 2 to 3 times. For every 10 degrees rise in temperature, rate of reaction is 2 to 3 times. Here, the graph in between kinetic energy and fraction of molecule. This is at temperature T. Temperature T. This is the temperature T. These are the fraction of molecules here at temperature T. If the temperature is plus 10 degrees centigrade, again plus 10 degrees centigrade more, then the fraction of molecules are more. If the fraction of molecules more, then rising temperature. This is about temperature effect. In next class, we will discuss about the temperature effect in a derivative form. Thank you. Thank you very much.